With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, the question is at 800 degrees Celsius, the following equilibrium is established as F2 gaseous, it forms 2F gaseous. The composition of equilibrium may be determined by measuring the rate of effusion of the mixture through a pinhole. It is found that 800 degrees Celsius and 1 atmospheric mixture effuses 1.6 times as fast as SO2 effuse under the similar conditions. Atomic mass of F fluorine is given 19. What is the value of the Kp in atmosphere? So in this question it is given that at 800 degrees Celsius this equilibrium is established and this composition of the equilibrium is measured or determined by measuring the rate of effusion through a pinhole. And it is found that 800 degrees Celsius and 1 atmospheric pressure, this mixture effuses 1.6 times faster as that of SO2 under similar conditions. So we have to find out the value of Kp. So first of all, according to Graham's law of diffusion or effusion, for the gases, their rate of effusion, it depends on the molecular weight as inversely proportional to the square root of their molecular weight or molecular mass, or we can say atomic weight. So this is the relation between them, that rate of effusion of any gas is inversely proportional to the square root of its molecular or atomic weight. Now we are given here that this equilibrium mixture, it effuses 1.6 times faster as that of SO2. So we can write the rate of effusion of mixture divided by rate of effusion of SO2 is equal to under root of molecular weight of SO2 divided by molecular weight of mixture. Now our mixture, that is rate of effusion of mixture, is given 1.6 times the R, that is rate of effusion of SO2. So we can put this value here. It will be this divided by rate of effusion of SO2, and molecular weight of SO2. Molecular weight of SO2 is 64 gram per mole. So it would be 64 gram per mole divided by molecular mass of mixture. So we can calculate molecular mass of mixture from here. That would be, this is cancelled. So it will be, this is square root on the right side, it will become square of this. So it would be 64 gram per mole divided by 1.6 square, which is equals to molecular mass is calculated as 25 gram per mole. So this is the molecular mass or weight of the mixture. Now this is the molecular mass of the mixture, and the molecular mass of the mixture, this will be equal to the mole fraction of the fluorine, mole fraction of fluorine into its molecular weight of fluorine plus the mole fraction of fluorine, F fluorine atom, into molecular or atomic weight of fluorine atom. Now we have the equilibrium as F2 gas, it forms 2F. Now if we say the mole fraction of F2 is, mole fraction of F2 is X, so for 2F it will be 1 minus X, because mole fraction of any two constituents is equal to 1, so it will be 1 minus X. Now we have the molecular mass of mixture is 25 gram per mole, and the mole fractions are X and 1 minus X, so we can calculate the value of X from here. So it would be, molecular mass of mixture is 25 gram per mole, mole fraction of F2 is X, into molecular weight of F2 is, atomic weight of F is given 19 gram per mole, atomic weight of F. So molecular weight of F2 would be 38 gram per mole. So it would be 38 gram per mole plus mole fraction of fluorine atom is 1 minus x into 19 gram per mole. So from here we can calculate the value of x. It would be 25 equals to 38x plus 19 minus 19x. So it would be 38x minus 19x equals to 19x plus 19. And here it is 25. So 25 minus 19 is equals to 6. And x is equals to 6 by 19, which is equal to 0.316. So we have x is equal to 0.316 and it is the mole fraction of fluorine. This is the mole fraction of fluorine F2. So mole fraction of F will be 1 minus x. So it would be 1 minus 0.316. So it would be 0.684. Now we have to calculate the value of Kp, that is pressure equilibrium constant for this equilibrium reaction, and Kp is equal to partial pressure of the products raised to power their stoichiometric coefficient divided by the partial pressure of reactants raised to power their stoichiometric coefficients. It is how the Kp, that is pressure equilibrium constant, is calculated. Now if we write Kp for this reaction, it would be, the reaction is this, so it would be products, partial pressure of products, so it would be partial pressure of fluorine atom raised to power its stoichiometric coefficient divided by partial pressure of fluorine molecule. So partial pressure is calculated as the mole fraction into total pressure. Partial pressure is calculated as mole fraction into total pressure. So now we have calculated the mole fractions for fluorine molecule and fluorine atom. So if we multiply this by total pressure, we can have the partial pressures of both, and the total pressure at equilibrium, it is given as 1 atmosphere for this equilibrium. So it means if total pressure is 1 atmosphere in this case, so partial pressure will be equal to mole fraction. Partial pressure will be equals to mole fraction because the pressure total is, or total pressure is 1 atmosphere. So we can write partial pressure of fluorine atom, it would be mole fraction. Its mole fraction is 0.684. So it would be 0.684 square divided by partial pressure of fluorine molecule, which is equal to its mole fraction, that is 0.316. So when we calculate this, it will be equals to 1.49 atmosphere. So this is the value of the Kp, that is the pressure equilibrium constant, 1.49 atmosphere. So the correct answer to this question is D option, that is 1.49 atmosphere. I hope you understood the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.